Hello everyone and thank you for participation. My name is Javad Majruhi Sardrud. I'm Associate Professor at Azad University of Central Tehran Branch, Department of Construction Management. Today I'm going to discuss about automated management of construction materials using RFID technology. My research interests are automation in construction, building information modeling, green building, 3D printing in construction, and smart cities. The presentation has 5 sections. The first section is construction management, focusing on materials management in construction. Then automation technologies. In the third section, we will discuss about RFID technology overview. In the fourth section, we will propose an automated management system for construction materials, and the final section is conclusion. Every type of project, such as buildings, roads, dams, and bridges, could exploit wide range of technologies, including identification, positioning and locating, and data transmission to manage material flow and supply chain. Normally, material will follow a same route to be delivered to the construction site. Bulk material, prefabricated and engineered material should be manufactured off-site and then transported to the project site. In this section, we have some outlines to discuss about. First, we have a description about construction industry, project triangle, and processes. Then we will go through the project management knowledge areas, focusing on resource management, and among all of the resources, we will focus on materials management. Today's world demand increasing construction projects and massive urban development projects. That these projects could be influenced by extremely complex engineering and performance or dynamic environments, uncontrolled condition, and unprepared team. Harsh conditions such as wind, dust, rain, mud could be impact on projects negatively. By definition, a project is a complex, non-routine, one-time effort limited by time, budget, resources, which is undertaken to create a unique product or service to meet the needs of a stakeholder and beneficiaries. Project management is the discipline of planning, organizing, and managing resources in such a way that the project is completed within defined scope, quality, time, and cost constraints. In construction, project management is a professional service that applies effective management techniques to the planning, design, and construction of a project from inception to the completion for the purpose of controlling time, cost, and quality. Every project have 5 phases of initiating, planning, executing, and in parallel with executing, we have controlling and closing. All of these stages are to satisfy cost, time, and scope or quality as a project management triangle. Construction is recognized internationally as one of the information-intensive industry and subject to harsh conditions, which is often criticized for delivering projects late and over budgets. Among all of the knowledge areas defined in PMBOK or Project Management Body of Knowledge, we are going to discuss on project resource management. But what is a resource? We have 4 types of resources in construction: manpower, machines, and materials. We call them physical resources, and money. The construction industry is often criticized for delivering projects late and over budget due to failure in effectively managing construction resource, especially materials, and in accessing the related information. To have a successful project management, we need to have an effective management on materials. Materials may count for 50 to 60% of the total cost of a typical project. On construction projects, hundreds of materials go through design, fabrication, interim processing, delivery, and storage prior to scheduled installation. We can divide materials into three different categories of long lead bulk materials, standard off-the-shelf materials, and engineered items. Engineered materials are the materials with a unique identification number can be uniquely identified during the project lifecycle and are specifically fabricated for a particular project, such as pump. Engineered materials are the most visible, costly, complex, and quality critical. Bulk materials are the materials manufactured to industry codes and standards and are purchased in quantity. For example, bulk materials are sands or something like this. Loose materials such as structural timber. Packaged materials such as tiles. Bagged materials such as cement and pallet materials such as doors. Basic principle of materials management is effective management mechanism for planning and controlling all of the efforts required to guarantee the proper quantity of the right materials at a reasonable cost when they are needed for installation. To have a successful material management, we need to satisfy planning, organizing, staffing, directing, controlling, reporting, and budgeting requirements to reply concerns of purchasing, expediting, shipping, receiving, storage, inventory control, handling, installation, and eventually disposes of the surplus of materials at the end of the project. Materials tracking processes for the construction project have three steps. In first steps or offsite prefabrication, we need to quality control, handling and storage and picking up and loading the material. Then we need to ship the material to the construction site, and on site we have different tasks: receiving, handling and storage, recalling and flagging, assembling and manufacturing, picking up and loading, installation and inspection. And during all of these three steps, we have to report the status to the project management system. Offsite production status from creating or manufacturing, quality control, handling and storing, picking up and loading are called offsite construction material management, and on-site status from receiving to installation inspection called on-site construction materials management. Handling of materials, for example, must be performed safely, efficiently, at low cost, in a timely manner, accurately, and without damage to the material. And for material handling, some design criteria should be considered. Material characteristics, for example, state of matter, size, weight, shape, condition, risk of damage to the material, safety risk, and corrosive, flow rate, routing and scheduling, plant layout, and unit load principles should be considered. Lack of materials when needed, poor identification of materials, and inadequate storage are causes of delay or unnecessary work that result in late deliveries, double handling, and misplacement of materials, which lead to loss in workforce productivity and increase overall project costs. For example, if the materials are delivered too early, the contractor's money is tied up in the material inventory. The space on the job site has to be allocated for storage, and these materials could be subjected to pilferage, breakage, or spoilage. On the other hand, if they were delivered too late, negative impacts on the program will occur. Some of the major problems which concern construction materials management are including materials required but not purchased, materials purchased but not received, materials arriving to the site at the wrong time, materials arriving to the site in the wrong quantity, materials whose specifications do not match the ones in the purchase order, unavailability of information regarding the status of the orders, missing or surplus of materials, lack of storage space of materials on site, lack of up-to-date information regarding on-site stocks, lack of complete and up-to-date information regarding arrival of materials, materials that are issued to craft and are then not used or installed, waste of man-hours searching for materials and tracking them, and extensive multiple handling of improperly sorted materials in search of required pieces. Material management is to get right quantity of supplies, the right quality at the right time for the right cost at the right place. Benefits we expect are improved staging area management, significant reduction in laydown yard size, effective material laydown and warehouse management, reliable location results, reduced number of missing components, repeatedly find equipment for maintenance, reduce warranty problems, increased productivity and avoidance of delays, reduction in man-hours needed for materials management, reduction in the cost of materials. This is due to reduction in waste caused by manual and inefficient materials management and control. In material management, we need to share information amongst all the parties, such as owners, consultants, suppliers, and contractors. Existing methods for managing and controlling are manual recording by paper-based documents, paper-based information communication, and non-automatic information management activities that faces with challenges of large complex sites, storage, international project nouns, material receiving, changing workforce, uniquely identified engineered items, and weather, unplanned, unscheduled, and unforgiving. Other problems in material management are untrained workers, the reluctance of workers to monitor and record, lack of proper supervision of construction work, misrecording information, misplacing data and results, changing workforce, and difficulties of reassessing to data. Therefore, disadvantages of the existing method is time and labor intensive methods, human errors and problems, not reliable or complete, not provide real-time status information, and difficult and not suitable for harsh conditions. To compare manual data collection and automated data collection, we have to consider each one's characteristics. Manual data collection is paper-based and it's difficult to search and access information. Also, this system is unreliable and incomplete. While by using technologies and getting to automated data collection, we have access to accurate and errorless information. In this system, we will not lose any information and it will be in access whenever we want. Tasks could be benefited by applying automated material management are as follows: material takeoff, material requisition, awarding material contracts, material inspections, material shipment and export, receipt of materials, material storage, in-storage maintenance of materials, issuance of materials to contractors, material installation, material return, equipment startup, and project turnover. Thank you for your time and kind attention. In the next section, we will talk about automation in construction.